Okay, get ready for this. What if I told you that everything around you, the stars, the screen you're looking at, even your own thoughts, isn't made of matter or energy at all? What if it's all just code? I know, it sounds like something straight out of a movie, but we're about to dive into a theory that says this isn't science fiction, it's fundamental physics.
And here's the core idea we're going to unpack today. This isn't some cute analogy. The claim here is that reality, at its very root, is literally a computational process. It's running on a single fundamental program that kicked off at the very beginning of time.
So here's how we're going to tackle this. First, we'll look at why physicists are even asking these kinds of questions. What's broken that needs fixing? Then, we're going to unveil the single line of source code that supposedly runs everything. After that, we'll see how familiar things like space-time and even matter just pop out of that code. And finally, we'll get into the really mind-bending stuff, what all of this means for us. All right, let's start with the big problem. You see, for the last 100 years or so, physics has been built on two incredible theories that absolutely hate each other. On one side, you've got Einstein's general relativity. It's beautiful, it's smooth, it describes gravity and the large-scale universe perfectly. But on the other side, you have quantum mechanics, this jittery, probabilistic world of tiny particles. And look, they both work like a charm in their own lanes. But when you try to bring them together, say to describe the inside of a black hole, the math just completely falls apart. It's not a small issue. It's a deep, fundamental contradiction at the heart of physics. So this leads to a really wild question. What if the problem isn't with the theories themselves, but with the very foundation we've built them on? What if we've got the basic nature of reality all wrong? This new idea says, let's stop thinking about the universe as being made of stuff, matter and energy. Let's start thinking of it as being made of information. It's taking that old idea, it from bit, and cranking it up to 11. Okay, so if the universe really is a computation, right? It's got to have an operating system. And the claim of this theory is that the entire sprawling OS of reality can be boiled down to one single, incredibly elegant rule. The model they propose is something called a quantum cellular automaton, or QCA. Just picture a giant cosmic grid, like a chessboard that fills all of existence. And on every single square, there's a little bit of quantum information. With every tick of some universal clock, each square looks at its immediate neighbors, and only its neighbors, and updates its own state based on a simple rule. That's it. It's simple, it's local, and as we'll see, it's unbelievably powerful. And this is it, the whole shebang. They call it Axiom Omega. This one sentence is the proposed source code for everything you see. It basically describes a system where information evolves perfectly. Nothing is ever created or destroyed, just rearranged. From this single starting point, with no pre-existing space or time or particles, everything else is supposed to emerge. So let's just quickly break that down into computer terms. This theory says reality has just three basic components. You've got the grid. Think of it as the universe's hardware, the pixels of reality. Then you've got the states, the qubits of information that live on that grid. That's the software. And finally, you have the rule, the one single update function that acts like a cosmic CPU, processing all that information, tick by tick by tick. Okay, so if we just run with that, if we assume that single axiom is true, what happens? Well, the very first thing that pops out of this cosmic simulation is space-time itself, and it comes with a speed limit built right in. And the logic here is actually super simple. It's kind of brilliant. If information can only ever move to an adjacent pixel on the grid in one tick of the universal clock, then there's a hard limit to how fast anything can possibly travel. And this theory says, well, that's all the speed of light is. It's not some weird magic number. It's just the maximum data transfer rate of the universe's hardware. Now, from that universal speed limit, you get this really cool core principle. They call it the conservation of information celerity. It basically says that every single object in the universe has a total constant speed through reality, and that speed is always z. But, and this is the key, that speed gets split between two different jobs, moving through space and changing internally. And this equation right here shows you the trade-off. Your external speed, squared, plus your internal speed, squared, has to equal the speed of light squared. It's like the Pythagorean theorem for reality itself. And the consequences of this are just absolutely wild. Think of it like a video game character with a fixed amount of energy. It's a zero-sum game. The more of your reality budget you use to move through space, the less you have left over for your internal processing. And what is internal processing? Well, it's everything else. It's your watch ticking, your heart beating, your brain thinking. It's what we experience as the flow of time. So time dilation, this weird effect Einstein talked about, suddenly makes perfect sense. It's not weird geometry, it's just your system being too busy moving to have enough processing power left over to age. So if space-time just emerges from running this simple rule, it begs an even bigger question. What on earth is matter? In a universe made of pure information, what are we made of? Well, in this picture, a particle without mass, like a photon of light, is just a simple ripple of information. It's a clean pattern moving across the grid. It spends its entire processing budget on external movement, which is why it travels at sea. But matter? Oh, matter is something else entirely. Matter is what happens when information ties itself into a stable, persistent, self-referencing knot. It's a complex loop that spends most of its processing budget just maintaining its own intricate pattern. And that's exactly what mass is. Mass isn't some property of stuff. Mass is simply a measure of the computational cost required to keep that information not tied together. It's the internal processing power that vis internal needed to sustain a particle's existence from one moment to the next. In a very real sense, mass is the price of existence. And get this isn't just some wild guess. The idea that a fundamental particle has some kind of internal vibration is a real, though incredibly strange prediction from standard quantum mechanics. It's a phenomenon called Zitterbewegung, which is German for trembling motion. This new theory gives it a clear, intuitive meaning. It's the particle literally processing its own existence. It's the vibration of the knot. So, if all of this holds up, if reality is just code, if space-time is the result of that code running, and matter is a knot in that code, then we arrive at the final, truly profound section. This is where we go full-on cyber sci-fi. You have to ask the question, what does that make us in this cosmic computer game? Are we just NPCs, non-player characters just running out our pre-written scripts? Or do we have any say in the matter? This theory offers a really stunning answer. It says that consciousness isn't some magical ghost floating around in the machine. Consciousness is the machine, operating at its absolute highest level of complexity. It's the most intricate, recursive, self-aware information pattern that the universe's QCA has managed to cook up so far. And this all leads to this beautiful, poetic conclusion. You start with it from bit. The physical world, the it, emerges from information, the bit. But then it goes deeper. We are the bit. We aren't separate from this process. We are living, breathing computations. And then, the final step. We make the it. As the most complex computational structures in the known universe, we might have the potential not just to observe reality, but to actually shape it. Which leaves us with one last crazy thought to chew on. If physics eventually stops being about discovering fixed laws and starts being about understanding a program, well, then it could become an engineering problem. If we could, one day, get root access to the source code of reality, what would you change? What would be the very first line of code you'd write?